I'll be alive. Okay, sounds good. Okay. You guys see my screen? I want to make sure. You guys see my screen now? Oh, can you guys hear it? Can you guys hear and see it? Can you guys hear it? Okay. Now can you guys
Wow,
hear?
this is useless. Then about 20
Okay, I think you guys can hear it now. Anyways, this is a video about history of programming. It's pretty interesting.
in the beginning, there was nothing. Then someone invented 1, and then someone else invented 0. And everyone said, wow, this is useless. Then about 20,000 years later, electricity shows up. Electricity likes on and off. On is 1, off is 0. Suddenly, we're programming stuff. They say, what if we combine 1 and 0? So they do. 1 0 1 0 1 0 1 0. Nobody knows what it means, but it feels important. 1936 rolls around. This guy defines what computable even means. He goes on to crack the Nazi Enigma machine to save the war for Britain, but he's way too gay, so they throw him in prison. The war is over, and people realize computing machines are pretty useful. They use vacuum tubes and punch cards to represent ones and zeros. They call each number a bit, or a binary number. It's how computers think. They don't understand words, they understand voltage. And then someone had the idea, what if we take 8 bits to represent a regular number? Everyone agrees. And now we can count to 255. Then this guy says, dudes, let's call this 8-pack of bits a byte with a Y to make it sound futuristic and cool. And now people start arranging ones and zeros all day to make machines do math, and they realize this sucks. So this woman shows up and says, absolutely not, and invents assembly language. Instead of writing 10110000, you write MOV. It still sucks, but now it sucks less. Then another woman shows up and completely changes everything. Grace says, what if computers could understand something like English? Everyone laughs. They tell her to go make a sandwich, so she does, and calls it a compiler. A compiler is like a translator. You give it readable code, it thinks really hard, then gives you a new file. That file is machine code, a bunch of ones and zeros again. The computer loves it, you never look at it again. This leads to the first high-level programming languages. Fortran for scientists, COBOL for businesses and government. Somehow, half of global finance still runs on COBOL. No one knows how, no one touches it. Meanwhile, this weird guy creates this weird language called Lisp. Everything is a list. Code is data, data is code. It doesn't even need a compiler. Instead, it uses an interpreter that runs code line by line on the fly until the code stops working. Wild stuff, and it also unlocks a new superpower called garbage collection, where the programmer no longer even needs to think about memory. After everyone does LSD in the late 60s, things start to get weird in the early 70s. Dijkstra says go-to statements are trash, and everybody agrees that we need readable, maintainable code. Dennis invents C. C is fast, C is powerful, C lets you shoot yourself in the foot with military precision, but C lets you talk directly to memory, which means power. Dennis has a buddy named Ken. Together, they use C to make Unix. It's an operating system. It's not the first one, but it's the only one that still matters. Instead of one giant machine, we get small programs. They each do one thing well and pipe data to each other, like CD to change directories and LS to list out its contents. The idea infects everything, and now the command line becomes religion among programmers. Everything was perfect, then this guy comes along and says what if C, but with more abstraction. So he adds a plus to it, and then another plus. And now all of a sudden, we have objects, classes, inheritance, and arguments that never end. Programmers love complexity, so C++ takes over the world. Games, browsers, databases, engines are all built with C++ even today, and people still can't stop arguing about it. Now the year is 1982. Every nerd owns a Commodore 64 while learning how to code in BASIC while listening to Thriller on a record player. Soon, Turbo Pascal shows up. Like C, it has a compiler, but also a full integrated development environment. It sells like Thriller, but many new programming languages are hitting the scene. Ada is created for the military, Erlang for the phone system, MATLAB, Perl, Objective-C, and more. Oh, and don't forget Smalltalk, one of the first pure object-oriented languages where everything is an object. Everybody forgets about it, but everybody copies it. Then the 90s happen, and three philosophies collide. Guido says code should read like thoughts, so we get Python, where readability matters and indentation is law. But James says programs should run everywhere, so we get Java, where you write once and debug everywhere. Java doesn't just ship a language, but also a revolutionary virtual machine, which is like a fake computer that runs in the real computer and compiles Java to bytecode instead of machine code. It's basically cheating to get Java to run everywhere. But then Brendan comes along and invents JavaScript in 10 days to make buttons animate in the browser. It was supposed to be small, it was supposed to be temporary. It now runs servers, phones, databases, and spacecraft. No one planned this, no one wanted this. Then the World Wide Web happened. The experts said it would be no more important than the fax machine, but billions of websites were created anyway, most of them with PHP. Nobody likes to talk about PHP, only JavaScript frameworks. Wars were fought over JavaScript frameworks like jQuery, MooTools, React, Angular, Vue, Svelte, and thousands more. Many people died from unrelated causes, but they didn't die for nothing. Throughout the 2000s, languages became cleaner and more elegant. Swift fixed Objective-C, Kotlin fixed Java, TypeScript fixed JavaScript, Go fixed C, Rust fixed C, no, Zig fixed C, JK, C is still the best. In 2020, the world is beautiful and perfect. Programmers are cool, programmers are rich, and programmers are highly desirable mates. Even Fireship was making good videos without any AI slop. But then, the asteroid hit. Someone says, what if we can get statistics to write code? First it's autocomplete, then linters, then refactors, then whole functions, then entire full-stack applications. And suddenly, everybody says, programming is dead. But here's the secret. Typing code was never the job. The job was thinking. Thinking with your brain. Programming isn't dead, it just keeps changing the keyboard, and it always will. And one tool that's changed the way I use the keyboard comes from JetBrains, the sponsor of today's video.
So that was the video. And interestingly, when you guys learn computer science in university, they go the opposite way, where they teach you Python, then C++, C, and assembly, and on. Anyways, I sent a live share in the chat, so go ahead and click on it, and it will send you to the Connect 4 that we were working on, and also Charlie. I'll send you the link to the GitHub for your own reference in the chat as well. And that's for this week. And the code that is already implemented, or what we finished last week, I'll just show you guys just once again what we're working on. Okay. And let me know if you guys ever can't see my screen. Okay. So we're working on the Connect 4. And we have this board class representing our game. We have the alpha beta, which we won't work on because we already implemented this multiple times. So on your off time, you guys can go ahead and try and implement the alpha beta pruning and see how it works. And just to help you guys, I already have the alpha beta done for the game loop. So once you guys are done the alpha beta, all you have to do is use this play human versus AI, change the if name equals main, uncomment out the play human versus AI, and it will work. Anyways, yeah, we have the alpha beta, and then we're implementing the Monte Carlo tree search. Then we're going to do the Q-learning agent, and then play human versus AI is done. And then we'll implement the two game loops, one for Monte Carlo tree search, as well as Q-learning. If there's no questions, go to the next. I see 4 people here, 2 people. Okay, let's get started with Albert. if you can share your screen and open up the link. I think you already have it, though. And Adam, you'll go next. So just open up the link like Albert has done. And Albert, you're gonna go down to, let's see, last time we went up to check winner. So it's line 80, 80. Yep. So we have our check winner function, and we defined a new function inside it called run length. And this is gonna be basically, where are we? Line 80. Here it is. This is basically gonna scan our row or column or the diagonal and check how many winning pieces there are. So that if there's four in a row, then so on as one. So now what you'll do after the run length function, so you'll go to that line. No, it's in the same check winner function. Oh, I think you're on the wrong file. Go to code folder. Yep, week 6. Yep, template. You'll go to line 80, and it should be there. So go down. Oh, where are we? Yep, run length function. That one's already done, so we'll go under that. So that means go to line 103. Yep, tab, all the way to tab, tab. Yep, right there. So now what you're going to do is you already implemented the run length function, which checks if there is a winner. So we'll now have to go through each horizontal and the vertical and the diagonal, both diagonals, so that we run this run length function to check if there is a winner. Make sense? So let's implement that. We'll go horizontal first. Go back to that tab 3 times, I think. Yeah, right there. So you'll do, what do you think? We want to check each horizontal row. Yep, for loop, and give it a good name, R or row or in all caps, I mean, range of, in range of, range of the function. Yep. And then all caps rows. Yep. That one. Yep. Enter. Now we want to check run length. So do if run length. Inside the run length, if you hover on it, it says we're giving it a line. What line are we giving? It's the row. So we input self.grid, that's the board, and the grids are row. So for NumPy matrices, yeah, I can't see too. Yeah, that's right. And then comma. Yep, good job. And then we want to check if this is greater than or equal to the win length. Yeah, win length. Good job. Next line. Remember that it's an if statement, so you need the colon. No, where the after the if statement, like yeah. Enter, and then we want to if run length returns true, I mean greater than win length, then that means someone won. So now you want to return. And what does I mean, check winner return? It returns, we want to return the grid. So we want to return self.grid. Yep, self.grid. And then the row, R, yep, comma, NP, as in NumPy, dot argmax, ARG max. And then we want to pass in the self.grid. And it's the R and then the colon. So when you guys do indexing, when you guys have, let me type in the chat. Grid. The colon means everything in that row. So we're passing that row that we have, and we're checking if it's not empty. So what you want to do here is if np.argmax of r comma colon does not equal empty. Weird. Try it again. I've sent a new link. Okay, weird. Anyways, back to, oh, wrong file. Yep. After the square bracket, np.argmax, and we're inputting into the argmax the self.grid. So this part. So delete the R, yeah, and then do self.grid, square bracket, yep, R comma colon. And then outside right here, we do does not equal empty. Does not equal. No problem. It's exclamation mark equal. We're gonna put that inside. And then we're gonna do not equals empty all caps inside the square bracket. Yeah, good job. Now let's just copy that row 3 lines. So the for loop. And we're gonna make a copy of it under it. And we're gonna change it so that this one goes through all the columns. So how would you change it? Yep. Uh Cols is COLS. And one way you would check is going up to the way top of the file, but you don't need to do that. Yep. For CN range columns, you want to check if the run length, but now you don't want to pass in the row, but the column. So how would you change that? So for line 109. Yep, good job. Now the next line as well. And the self dot grid inside the argmax. Yep, good job. Now we'll go diagonal, but for the diagonal, I'll probably just show you guys since it's pretty hard one. So you can just stop sh sharing your video screen, or I'll share you guys my screen. Okay, I think you guys can see this. Okay, let me know if you guys can't see my screen. I'll go ahead. So now we're going from the top left to the bottom right. So we're doing range of, does anyone know what the syntax is? Or understand what we're going with this one? We're going from negative rows, where rows is 6. So it's -6. Where is it? -6 plus 1, which is 5, -5. And columns, where we hover on it. I keep losing the, here it is. And it says literal 7. Does everyone understand what this does? Range of -5 to 7. It just goes up by 1, right? Now what we're doing is we're using the diagonal function from the NumPy library. We're passing in the offset, we're passing in the grid, and we're getting that diagonal. And diagonal is basically going to be a NumPy array. And we're passing in this array into run length like we did here. So it's basically a column or a row, but in this case, we're creating a diagonal array. And we're doing the same thing, checking if it's empty. If not, we want to return. And we just do the opposite for the other diagonal way, which is top right to the bottom left. Next, we'll implement evaluate. And for that, we'll do give Adam chance to share your screen. So whenever you're ready, Adam, can you share your screen? It'll be the evaluate function in the board class. Adam, do you really want to do it on Replit? You can if you want, though. And it will
Okay.
be at the top. I think you're going way too down. Uh, Up, up.
Where is it?
Is right under is full. So yeah, go down. Go down, 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 down. Oh, you don't have it. So let's just create a new function. Enter. After 1395. Before that. You can just do it there. And go down to 1397. It's because that whole thing is commented out. Whatever you put inside it, it won't be. Actually, try it. Let's just do it. Define. So we want to define a new function. Evaluate. Although the thing is, you need the board class. Let's just so define. Do you know how to make a class? Let's just make the function then. Define evaluate, and we pass in self evaluate with a A. You forgot. Yep. And inside the argument, we pass in the self and player. Player. Yep. And since it's a function, colon, enter. And now I'll just tell you what this function does. Basically, it's a heuristic evaluation of the board from the point of view of the player. So positive points. So heuristic evaluation basically means we're giving them a point based on how the state of the board. So if the player is winning, then it's a positive point. If it's bad for the player but good for the opponent, then it's a negative point. So let's basically what we're gonna do is what you guys count. Okay, what do you guys think counts as a good state of the board for the player? So
There are
how what
things connected.
yep, exactly. So basically how would you put that into code? You want to count all the connected pieces. So you want to count how many of two in a row that we have and three of a row, right? Since that basically says we have a lot of connected pieces. So we'll do plus 10 for each three in a row, and then plus 1 for each two in a row. So we'll do opponent. You want a tab. Remember that's a function. Yeah. Your whole thing is in commented out. So what you're gonna do is go to line 1396, do triple quote. Yeah,
There's a
1396.
virus on my computer.
Yep, exactly like that. And then go down to 1398, and then you can start typing again. Opponent equals player one, all caps player one. If player equals player two, or else player two. Enter. We're gonna create a new function inside that function called count patterns. So create that function, define count patterns, which we pass in p underscore. That's no, just p. Yeah. Exit. Yeah. Colon for enter. Yep. Count two comma, count 3. See, yeah, count 2, comma, count 3 equals 0, comma 0. So another way you guys can define variables, if they're the pretty simple like this, you guys can just use commas. Now we're gonna define another function inside that count patterns function. So enter, define scan, and we pass in the line.
Define what?
Scan, SCAN, pass in the line. Yep, colon, non-local, count 2, count 3. And then n equals the length of the line. Yep. And then we're going to do for I in range. It's going to be length, just length. So len is how we get the length of a array or a list. Yep. And then we're going to do a for loop for I in range of n minus win length plus 1, n minus all caps win length. Okay. Win length has a underscore in between win and length. Yep. Colon, since it's the for loop. Enter. Window equals line. Yep. From I to I plus win length. Yep. Enter. Now we want to check and count pieces of player P. So if win.count, input P, win.count, count is a function. Do you guys know what the count function does? Yeah, it counts, but basically you pass in a string and it counts how many of that string is inside the list or array or. But yeah, win.count. Pass in P equals 3. We're not counting how many people won, but how many people like are 3 in a row. And window.count empty equals 1. Yeah, equals 1. Yep. If it is, then we want to check if I is greater than 0. And line I minus 1 is empty. Uh, you're gonna have to wrap that whole thing in a parentheses. That's only one of the conditions. Close bracket, and then open bracket at the start of the function, the loop. I mean, if. Right after if. No, right after if. Yep. And should be right after the closing bracket. Actually, or. So delete and then put or. Wait, no. I greater than 0 and then that one should be or. Yes. Okay. And then the other side of or. Sorry, it should be like, so we have the if circle brackets or like this. No, no, but yeah, like this. We have if this statement or this other statement. You would never do like if or right away because that's not a conditional statement. And this is also what I can't do with Replit is that I can't really help you with. So you have to go after the empty. No, no, no. Outside the bracket. Yeah, yeah. Right there. Or. Yep. Go back to the okay. And delete the or. To the right of or, new brackets, circle. Yes, right there. I plus win length is smaller than n and n. Yep. Line of I plus win length. So we're indexing the line. Do you know what it means to index a line? It should be square bracket. No, line square bracket. If you do it like that, that means that you're creating a list with line in it. This would be indexing a line. Yep, I plus win length. Yep, equals empty. Yep. Then after that if statement, it's count 3 plus 1. And yep, no, you should count 3 plus. Yeah. And you can stop sharing your screen. I think it's better if I just do the rest of that function now. I'll share my screen. Okay, assuming you guys can see my screen. We have two inner functions, count patterns and scan. Right now, we're examining this list. So what you just implemented, we're trying to check and count the pieces of player P, checking first for 3 and then for 2. And then we're checking each horizontal, vertical, diagonal, both diagonals, and using this count patterns function to scan for 3 or 2. And we're doing it both for the player and the opponent, and we're giving a evaluation based off that, where my 3 means basically how many my my 3 basically means how many of 3 in a row I have versus how many of the 3 in a row my opponent has, and we're gonna multiply that by 10. And everything with just 2 in a row counts as 1 point, so we're just gonna leave it. It's basically just times 1, but times 1 doesn't matter. And for string, this is just a pretty printer, so that it prints our board pretty. We don't really need to implement that since there's no logic in it. And the next person, let's just get started with Monte Carlo tree search. I'll just I'll just show you guys the init function. So this is a class. So we have an init function to initialize the variables that our class has. Here we have a board, which basically refers to this board class, an instance of the board class. And then we have the player, so who the player is, and then wins, the number of wins we have, visits, the number of visits we have, and then the number of children we have. Now, why does it count wins? Remember that Monte Carlo tree search basically is doing a whole bunch of random playouts of this Connect 4 game. So it's basically playing like, I don't know, 500 games. We set it somewhere. Later on, we can set it in Monte Carlo tree search. Play human versus Monte Carlo tree search here. We set simulations to 60. So it's basically doing 60 random playouts of the Connect 4. And here we have the random playout function, which basically, as I said, randomly plays. And then simulate basically uses the random playout function by cloning the current board, applying the move for the player, performing the random playouts, and then counting how many of the playouts ended with the player winning. Now, Caden, can you share your screen? And Charlie you'll go next. So just get ready. Go to the left one, left file. Uh, if you see at the top, yeah, template. Click for template. No, if you see where the tabs are, a bit more up, like the file tabs. Yeah, there. Now, Monte Carlo tree search is gonna be line 229. You're gonna do the random playout function. Yep. So basically, you're gonna you're gonna check if the game ended using the check winner function and is full function. If the game is not over, then you're gonna pick one of the random moves, and then you're gonna make that move for the player, and then you're gonna switch the player and then keep randomly playing out the game. Yep, current equals start player or that check winner. That's fine. Although if you do board.check winner there, you also have to conditionally check. Like you're just calling it right there, right? You're not really doing something based off that. So, yep. Board.check winner. Weird. Do I have? One second. Okay. Uh, One thing here. You're calling board.check winner twice, and you're inside the if statement. You're calling a function. What's a better way of handling this? Do you know? Giving it, yeah, exactly. Check winner uh returns the player who won. So you can just save that in the variable and use that variable inside the statement. Return the winner, which is check win in your, and then we want to check if it's full. If it is, what do we do? Return empty, since it's a draw. And then, okay, it gives you the answer, but it wouldn't be, okay, you could do else, but yep, move dot. Okay. Basically, you're calling board.legal moves. If you hover on it, it'll say it returns a list, I think, or is it a NumPy? Okay, it says any. But basically should be a list, and it's basically calling random the choice, which you pass in the list, and it makes a random move, chooses a random move, saves it to move, and then you're calling board.make move, so you're making that move for the current player, and then you're switching the player based on if it was player one or two. You can stop sharing, and we'll move on to Charlie. Charlie, if you can share screen. And everyone, you guys can always stop me for any clarification or anything. Okay. And okay, good thing you showed this. So everyone, if you guys ever run it, it says no module named like something, like NumPy. What you're gonna want to do, you can do pip install NumPy. Pip is, yeah, don't worry. That's good. Pip install, pip space install NumPy. You could do that. If you guys ever do this, this is global. What does that mean? It installs it for, oh, then can you do I think it was WHP. So, oh wait, this is Windows. Yeah. Okay. But anyways, you would need to find out where your pip file is. Don't do that right now, but basically pip install NumPy basically does install NumPy for my global pip version, which you guys know what pip is? It's the installer for library installer for Python. And basically what happens if you download too much stuff on your global one, it becomes just, you know, too big for global. You guys shouldn't really do that. What you guys can do is create your own virtual environment. You guys can search how to do that, but basically what you would do is Python dash M. I'll just write it in the chat. What this means, we're basically creating a Python environment and we're calling it VM. Yours wouldn't work because we don't know where your Python file is. Do you know where your Python file is? Oh, one thing you can do, run it. Run the command. Run the file. Yep. And then go up arrow in the terminal. Yep. Delete up to the python.exe. Uh, that wouldn't work in the terminal. You just have to keep deleting. Or I think control delete should delete a lot more. No, it doesn't work. Okay, just delete. That's where your Python executable is. Yep. You're gonna do now. You're gonna do dash m. Oh wait, you already have it. Oh, I think you're in the wrong Git repository. Yeah. I'll show you. I'll share you the Git repository for this class. For this class, it's different. You're gonna want to go here. You're gonna do the same thing as before. You're gonna go to if you click the top blue one, blue link that says public to the right. Up. Uh, yeah. Code in green. Copy. You can just click the link. Yep. We're gonna go back to the terminal. And this is for everyone following. You guys can do the same, but Control C inside the terminal. No, you're gonna want to exit this line. Quit. No, no, no. Okay, okay. Just enter from here. So what you're doing right now is this is basically the Python executable. You're gonna want to quit from there. How you quit from a Python instance is you run the quit function. So quit, and then it's a function call. Yep. Now you do cd space dot dot. This basically means go back one directory, enter, and then you're gonna do git clone. No, no, git clone paste. You remembered what you copied? Yeah. Yep. Now you're gonna do file at the way top of the VS Code because you wanna open up this folder. Open folder, and then you're gonna open the folder which is right before this. It should be right there somewhere. Intermediates. Go down. Go down in the folder icons, right side. Yeah, go down. Right there. Bottom left. Yep. Open folder. Yep. Now go to code. Week 6. Connect for template. Down, 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 down to line 285. So, right. Yours is the older version, but go up. And I'll paste you a link in the chat. This is what we're working with in the class. This is basically something called live share. Basically allows us to work on the same files together at the same time. Just do continue as anonymous on the bottom right. Uh, is it not working? Weird. Enter. Okay, accepted you. Yep. Go to code on the left. Week 6. Connect for template. Go down to 286. 286. Yeah, simulate. That's the function we're going to create. So you're basically cloning the current board. You're going to apply the move. You're going to perform the simulations, which is the random playouts. And then you're going to count how many times of those random playouts this player or the user won. So delete the raise. Yep. So first, let's call and get the illegal moves. Okay. Go to, yeah, right there. So one thing here, legal moves, if you search for it or if you think about it, is gonna be a function of the board class. Since we're searching that board for the legal moves that we have, right? So what you're gonna do is we have a board instance in our Monte Carlo tree search node. So in that init function, inside the Monte Carlo tree search node, which is line 224. Yep. Init functions are always at the top of the class. Right there. 220, 237. Yep, that init function. This function initializes all the functions, I mean, not functions, variables needed for this class. If you go down a bit, we see that we initialize some of these variables. One thing important here, we see self.board equals board.copy, right? Basically, we're creating this instance of the board class, and we're using it for this Monte Carlo tree search node class. So we'll use this board's legal moves function. So how would you do that? You would do self.board.legal moves. That's how you would call the boards, and not any board, but this class's boards legal moves function. So now go down to the simulate function. Yep. So as I said, you do self dot. Oh yeah, self dot board legal moves. Is it not showing up? Weird. But yeah, dot legal moves, which is underscore moves. Good job. But yeah, anyways, if you guys are feeling fuzzy about this class data structure, I mean, data class, you guys should, data type, you guys should learn about it because it's pretty important when it comes to object-oriented programming. But it's not in the scope of the class since this is mainly AI and ML. Anyways, now we're going to do win counts. So win underscore counts equals, and it's going to be a dictionary. Why are we doing a dictionary? Basically, what we're going to do is we're going to map each legal move to a number. What is that number going to be? It's the amount of times after we make that legal move that we win. So basically, let's say moves 0, 1, 2, and 5 are the legal moves that we have. Then we're going to map each move 0, 1, 2, and 5 to 0 at the start. And then every time we win, we're going to add 1 to each. So let's say first one random playout, we put in move 0 and we won. Then we're going to do add 1. Then in that dictionary, it's going to be 0 mapped to 1, everything else mapped to 0. Does that make sense? Or am I confusing you guys? Anyways, let me know if you guys ever need me to explain them more. How you guys create a dictionary? Do you guys know how to create a dictionary? Does anyone know? And it's totally fine if you guys don't. But in Python, we call it a dictionary. Everywhere else, it's basically a hash map. I'm pretty sure you guys have heard of that. But anyways, it's basically a lookup table. So you'll do dict is one way, dict. It's a function, and we pass something inside it. That's one way. Or the other way is, you know how a list has square bracket or list function? Dict is basically a squiggly curly bracket or the dict function. So yeah, squirrely. I always basically just do the squiggly or curly bracket. Anyways, we're gonna now map it. So you could do, let's just do it the longer way. So enter after that, uh, after the closing bracket. Yep. Now let's for loop through all the legal moves. And remember I said we're gonna initialize each legal move in that dictionary with 0. So we're gonna do for move in legal moves, colon, enter. Win counts. Right. I should probably tell you guys. So to add something in the dictionary, you know how in lists we do like list.append? We don't do that for dictionaries. For dictionaries, you can do win counts and then pass in a key. And you guys can see how it's a square bracket, right? So this thing inside, we'll call it a key. Anything that gets returned, or the variable that gets returned, is called a value. So it's a key value pair. So what you're going to do is, for move in legal moves, we're going to do when counts square bracket. Yep. And then inside of that, we're going to do the move, which is move variable, equals. Yep. Yep. Equals 0, since we want to set it to 0. And that should be good, since we're just initializing right now. Another way that you guys can do it, I'll send it in the chat again. This way also sets it to everything to 0. Basically does for each M in legal moves. We're going to set M to 0. Now, if you guys are wondering why it's a colon, if you guys ever print, if you do print when counts right now, then it will show up as, okay, how would I do this in here? It'll show up as this, 2, 5, like this. And this is basically a key value pair of this dictionary. So after when counts move equals 0, press enter. So go below that line, outside the for loop. Now we want to do another loop, but for the move in legal moves. This is separate from when counts. Yep, for move in legal moves. Yep. Now we're going to do for something in range. You can just do a underscore. Remember that. Do you guys know what that underscore means? A range of simulations. Does anyone know what that underscore means? Nothing. Yep. So it's basically we use it when we don't need to set a variable for this range or something that we're looping through. Why do we not need it? Oh yeah, pass in simulations in the range function. If you go up a bit, you'll see that simulations is set to 60, I think. But it's basically the amount of times we want to simulate or randomly play out. It should be at the what do you call it? Header, function header? Just the function header. So simulate. Yep, right there. Line 285. I think you're going way too down. 285. Two. Yep, right there. Oh yeah, right when I mentioned that. So when you guys do a function in the class, you set self to always be an argument, but you can also set your own any other argument that you want that you don't want to be the whole class's self variable. So here we set simulations, which we only want to be a variable argument of the simulate function. So here we're ignoring what the range of simulation gets, since all we're trying to do is loop through this simulation times. So if simulation is 60, we're just looping through this 60 times, and we don't need the number. Anyways, enter, and then inside the for loop, now we'll do trial equals, and then we're gonna copy the board. So, or you can do like board copy, but equals board dot copy. Remember that copy is a function. Why are we trying to copy here? It's because we do not want to, because we're making a simulation, we don't want to actually change the board. We just want it to last until this for loop is, or one loop of the for loop is over. Now we're gonna make or call the make move function of this board. Remember that trial is a board. Make move. Make underscore move. Pass in the move and the self dot player. What would the move be? We see it here for move and legal moves on line 305. That's what we're passing in. And we're passing in the self dot player. I wonder why it's doing that. Weird. Anyways, winner equals weird. Here we're doing the random playout, so self dot random playout should be underscore. Yep. We're passing in the board, which is trial. Or actually, you can just hover on the random playout to find it out. We're passing in the start player. One thing here, though, we want to decide who the start player is. So we'll do player one, comma. Yep. Equals. I mean, player one if. Oh, no, no. After that player. If. Not equals. Yeah. So this is called an inline conditional statement. So we're basically you could do right before the winner statement, player one, player equals player one, and then do a conditional if player one, then set player to player one, else player two. But here we will just simplify that player one if self dot player equals player two, else player two. So here we're switching the player. So if the current player is player two, then we want player one to play next. Next line, if the winner is the current player, enter. Self dot player. Remember that current player is self dot player. Then win counts move plus equals one. Colon. Colon and tab, yep. Win counts equals, win counts move. Uh, Remember that win counts is a dictionary. So we're basically accessing the dictionary's move key. So this move key, and then we're adding that key's value by one. No, that was correct. Yeah. Now outside the for loop, both for loops. Yep. Best move, best underscore move, or best capital M or whatever, equals max of. Max is a function. We're passing in legal. Now, one thing here, I'll tell you guys something. Yeah, sure. So here we can use a lambda function. What is it useful for? Basically, we want to check each value of the wing counts, and we want to get the maximum value for each of the keys. So what you're going to do is comma key equals lambda m. So we're basically setting this lambda variable called m. Or actually, let's just do. And for each of this, we're going to do legal moves. Actually, not legal moves. What do we set when counts? Move. So we're basically doing for each key move, which is the legal moves, we're passing it in. We're going through the win counts move, which is the value, right? So it's basically how many times each of the moves won, and we're getting the max of it. Oh, see. Does that make sense? Even a bit? But yeah, how dictionaries work is by key value pair. So it's important for you guys to know that as well. And you can stop sharing, Charlie. Thank you. Now we have the game loop left. Ooh, I think Nicholas, can you share your screen? Do you need the link again? Here's the link. And share your screen whenever you're ready. Okay. I don't think he's online. James, can you share your screen? Or do you want to just up to you? Would you want to go for it or no? We'll just do like a game loop. It should be fine. We're not gonna do too much. We're just gonna do some if statements. Yeah, just open the link and then share your screen. Yep, sounds good. You can just do it in the web browser, I think. There should be an option. You're gonna want to go to code folder on the left. Weird. Can you reload the screen? I think it thinks you're in VS Code. Weird. Can you click it again? Guest user and then just enter on the guest user. You see that pop up on the top? Enter. And then I'll accept. And then you should see it now. So go to code on the left folder. Yeah, right there. Week 6 should be it. Go down to line 556. And it's basically just going to be a game loop. So you're going to print the board. Yeah, that one. You're going to print the board. If it's the AI's turn, we're going to create a Monte Carlo tree search class instance. We're going to call simulate. We're going to make the move. If it's the human's turn, we're just going to prompt the user for a move and validate that we can make that move. Should be pretty simple. So let's just set the board. So what you did there was right, but let's just set it to board equals, yep, board equals board. Although usually for variables, we do it under lowercase. Yep. And then board is a class, so you do like, it's kind of like a function, but different, but you do the circle bracket. Go back to the up line, board, circle bracket. No, no, right here, right here. Yeah. Okay. So board is an instance of that board class. So we'll do current equals because we want to set the current player, right? So let's just do current equals player one, all caps player one. Yeah, current, CU, yeah, all caps player. Should be like this. So player one is a function. So if you hover on it, try hovering on player one. It just say literal one. So it's basically already set. And where we set it is all the way at the top of the file, but you don't need to look for it right now. Yep. Enter. And then now let's do the while loop. So while true. Yep. We're going to print the board. Uh, remember that board, you can just do print board. Yeah. That could work. Another thing that could work, remember that we have a string class, string str function inside that board class. but you don't need to do that right now. If winner does not equal empty, one thing here we want to, before that, check if there is a winner. Winner equals like even before that, we do winner equals and we call the check winner function. Yep, winner equals board dot check winner. Remember that check winner is a function of the board class. We don't pass in anything. Now, oh, one thing here. This should be inside the while loop. Remember that we're checking every single loop, right? We don't just check at the start and then print the board and then one thing. Now you want to check who the winner is, right? Yep. If winner does not equals empty, empty should be all caps empty. Yep. If it is empty, I'll just do this one. You want to tell the user who won, but you guys don't really need to do this since it's just user experience. Break, or else we want to also check if the board is filled. Yep, board dot is underscore full. Yep, good job. Colon. Yeah, we'll just do a quick. That's good. And then now you want to check if current equals player one. Then it's player one's turn. So player one is gonna be the AI player. So we're gonna set the instance of the Monte Carlo tree search class. So if current equals player one, then we want to do MCTS, lowercase, all lowercase, since we're creating an instance of the class. MCTS equals now all caps MTCS. No, yep, good job. Inside it, we're passing in board and player. Yep. And then after that, we're doing move equals. You don't need to do that because that's hard coding it. We already have a player switch on every time, right? Yep. Enter. And lastly, right before, let's just do move equals MCTS dot simulate. Inside it, we're calling simulations equals simulations. Yep. And let's just end this for today, right here. And we'll continue this next week. Yeah, no worries. And the code that you guys finished today will be uploaded as connect4.template, and we'll complete it next week. And you guys will see the recording up later once I upload it. And yeah, that's it for today. See you guys.